Good day everybody, we've been given a beautiful question. We are expected to find the area. Now let me explain you the figure. We got a square O, A, B and C. Inside the square we have a quarter circle. OAC is a quarter circle. OABC is a square. Inside the quarter circle you got another quarter circle. So let me name it as O. This point I am taking it as D, E. ODE is another quarter circle. Now you are being given a line which is actually a tangent to the quarter circle OAC, and that point is D. Now this distance AF is 9 units and this point G CG is 6 units. So this is 6, this is 9, and we have been given only this, and of course this is a triangle. Let me name the triangle GBF is a triangle. It's a 90-degree triangle because it's a square, right? Now we are expected to find the area of ODE. We require the area of ODE. Now it's a quarter circle, and with these information we will have to start. So foremost, what I wish to do is I would like to draw your attention to the figure over here, to this part of the figure. Now from F is an external point. F is an external point, and from this point there are two tangents drawn to the circle, quarter circle OAC. Can you see that? From this point there are two tangents to the quarter circle. So that tangent is hitting the point at A and at D. So by two tangent theorem, we have used this theorem before. This means DF is equal to AF. Now since AF is equal to 9, this means DF is also equal to 9. So this point or this segment is equal to 9. Fine. So this is one part of the observation. Moving on. Now watch here. G is an external point. Also G is an external point, and from this point G we have two tangents drawn. There are two tangents drawn to the quarter circle. Meeting at C and at D. So this means I have CG is equal to DG. Now since CG is 6, this means DG is also 6. So place that. So this in turn would mean this entire line FG or GF is 6 positive 9, which is equal to 15 units. So you can place that GF. So GF is equal to 15 units. Fine. So we have got the hypotenuse side. Okay, now what I'm going to do is I would like to bring your attention to the quarter circle. Now OA is the radius. Now let me take OA to be equal to R units. Now if I were to take this, now since there are two quarter circles involved, I'm going to take this as R1. Now let me write that. I want the figure to be in focus, so I will use this part of the space. Now since OA is the radius and that is taken to be as R, this would mean, watch here, this is apparently the side of the square. So that would mean AB is equal to R1, which in turn is equal to BC, which in turn will be equal to OC. All of the sides will be equal to R1. So this entire side is equal to R1. This is equal to R1, but I want this GB. So GB is going to be R1 minus 6. This entire side is R1. I want BF. BF is going to be R1 minus 9. Fair enough. Now since GBF is a right triangle, this would mean by Pythagoras we got, what do we got? GB squared plus FB squared is equal to GF squared. So GB, what is GB? R1 negative 6 whole squared plus FB, what is FB? R1 negative 9 whole squared. What is GF? 15 units. That's going to be 15 squared. So expand this. This is R1 squared negative 12 times R1 positive 36 positive R1 squared negative 18 R1 positive 81 is equal to 225. So add up these two. 36, 81, 7, 117. Push them to the other side. 225 minus 117. This is 108. So you got 108 over here. R1 squared plus R1 squared is 2 times R1 squared. So negative 12R1 with 18R1. So what is that? 2030. So it's going to be negative 30R1. And you bring this to the other side. So you got 2 times R1 squared negative 30R1 negative 108 is equal to 0. You divide by 2. What do you get? You get R1 squared negative 15R1 negative 540. So this is what you have got. So now we need to get the value of R1. So that's exactly what I'm going to do now. I've got to move to the next page. Let me show you what we have got. We've got R1 squared negative 15R1 negative 54 equal to 0. We need to factorize that. So how are we going to factorize it? R1 squared negative 15R1 negative 54 is equal to 0. Right? Now 9 into 6, can we work out with this? No. 18 into 3, 8 3s are 24, 2, 3 1s are 3, 4, 5, 54, but we need a negative 54, and when we need to add this we get negative 15. So this is going to be negative, this is going to be positive. So 18 times 3, and if we add them we get negative 15. So this is going to be negative, positive, we multiply, we get negative 54. So that is beautiful. So you got r1 squared followed by negative 18 r1 positive 3 times r1 negative 54 is equal to 0. You take r1 out, you get r1 negative 18. You take 3 out, you get r1 negative 18 is equal to 0. So r1 negative 18, r1 plus 3 is equal to 0. So r1 is equal to 18 or r1 is equal to negative 3. We can't take this, it's a negative value, so we take this. So what have we got? This implies the radius of the larger quarter circle is equal to 18 units. Now that is just one part of the story, right? But we need to get the other part. What is the other part? The other part is to find the area of this quarter circle. Now let me take OE. OE is the radius, right, of the smaller quarter circle. So let me take that to be as x units, and let me take this. So if OE is the radius, definitely the portion ED is also going to be the radius, right? This is a quarter circle ODE. So if this is equal to x, so this will also be equal to x. Fine, fair enough. Now what I'm going to do is, I'm going to connect from O, I'm going to connect the point D, right? Now this is the point O. From O I have connected D. Now this is going to be the hypotenuse. Definitely this is going to be 90 degree, right? So if this is 90 degree, let me do it over here. Consider the triangle OED. So by Pythagoras, what do we have? By Pythagoras we got OE squared plus ED squared is equal to OD squared. OE squared is x squared and ED squared is x squared. OD squared we need, so this is 2x squared is equal to OD squared. Therefore OD is equal to root of 2 times x squared, which is equal to root of 2 times x. This is my OD. But watch here, what is OD? OD is actually the radii of the larger quarter circle. Are you following it? See, from the point O we are drawing it to the circumference of OAC, but OD is the radii of OAC. So this means root of 2 times x is equal to R1. What is R1? 18 units. So this means x is equal to 18 over root of 2. Now if you multiply by root 2 and root 2, this can be rewritten as 18 times root 2 divided by 2, which is equal to 9 root 2. This is my x. So this means the radius of the smaller quarter circle. What is the smaller quarter circle? ODE of the quarter circle, smaller quarter circle, I'm going to mention it as ODE, is equal to 9 into root of 2. But what do we need? We need to find the area of the quarter circle. So we need this area, right? So therefore area of ODE, smaller quarter circle, just mentioning it, is equal to pi r squared. But this is the quarter circle, so divide by 4. So this is equal to pi over 4 times 9 into root 2 squared, which is equal to 9 squared pi 2, root of 2 squared is 2 divided by 4. So 2 divides here, 2 times. So 9 9s are 81 pi over 2 square units. So that's a area. So this is the required area. So this is a lovely question. I hope you all enjoyed it. Please like, share and subscribe to our channel. Until we meet again. Thank you.